In section 4.5, we're going to be solving inequalities that involve quadratic functions. And there's really two different methods that we're eventually going to get to in order to solve these. So let me give you some examples that follow pretty closely to your homework problems. I've picked some odd problems from page 312 from your text, and you will be doing the evens. So this first set of problems, your number 4 and number 6, they're going to look like this. You're going to be given the graph of a parabola, and it's going to be your job. It's a two-part answer. Your job is to identify where f of x is greater than 0. Another way of saying that in just plain language is, where is this parabola? That's what the function is. Where is this parabola over or above the x-axis? Okay, so let's just shade in the part of the parabola that would be above the x-axis. Okay, now to get our answer, we're turning it more in terms of this. What are the x-coordinates on the part that I've shaded in red? So if we were to classify the x-coordinates for all of these points that are starting at -2 and going forever left, as the x-coordinates would be going left as this parabola goes up. So the way we would summarize that is we would say that it's all the x-coordinates such that x is less than -2, because that's the direction they're headed. We're going, inputs are getting more negative, and that makes then the parabola continue to go upward. But there's also these x-coordinates over here that represent x's that are greater than +2. Okay, so as x gets bigger than +2, that's what's going to make the parabola continue to widen and then go toward positive infinity on the y-axis. So we got a two-part answer really for x. All the numbers less than -2. Notice I did not say or equal to because the problem does not say or equal to. So all the numbers less than -2 for this side, or all the numbers greater than +2 for this side. All right, and that's the answer for number 3. Okay, number 5 is a combination of a linear function, that's the g function, and a quadratic function, that's the f function. And this one you do have to kind of be careful about because the units are in 2's. Both the y and the x-axis are in 2's. Okay, so what this says in words is, give me the x-coordinates that would tell us where the g function, which is the line, the blue line, is above the f function. Okay, so maybe some shading, you don't have to shade it, but maybe that will help us identify. So where the blue is above is really right in here. Okay, this represents the area where blue falls above. So the green is, in other words, below the blue line. Okay, so where blue is above, it's from this point down to this point. All right, and so with an inequality, we would say that that's the x's between -2. So let me get our bracket situated here. So we're going to have all the x's that fall between -2 for here and +1. And so since it says or equal to, we'll use or equal to in our solution. So this reads as all the x's between -2 and +1. All right. Just take that shading off. Okay, and now this says, the part B says, well, where is the f function greater than the g function? All right, so if you want to do shading, or maybe the shading helps you recognize that, we're talking about greater than being up here. And for what numbers, for what values of x would the f function, x coordinates, be greater than the g function? Well, it's pretty much everything else. We would be all the numbers from 1 and bigger, okay, were greater. And then up here, notice that the red line is greater. So that's all the numbers to the left of -2. Notice as we continue, as this red parabola continues up, the values for x are going to continue to get smaller or more negative. So basically we've identified two different areas. All of the numbers greater than 1, okay? And then up here, all of the numbers less than -2. So let's put that together in our inequality. And we typically do the small ones first. So less than -2 takes care of these going that way, or greater than 1. That takes care of these going to the right. All right, so I hope that helps for number 5, and hopefully it'll help you when you do number 6. Okay, so when you do 8 through 14, we're going to use a particular method. It's solving by graphing. Okay, so to solve by graphing, the first thing you want to do is find the x-intercepts. Another way of saying x-intercepts is solve the quadratic equation. So think of it in terms of an equation. Equation would mean that it equals 0. And then go about your normal routine to solve a quadratic equation. If it factors, that's the easiest way, and this one does factor, because factoring makes it pretty easy to see what the solutions are. We have two solutions, and those are our two x-intercepts. X is 0, x is 4. The AOS line should be right down the middle of those two. So I have symmetry at x equals 2. And you don't have to draw that dotted line. I just wanted to emphasize where the line of symmetry is. The vertex is got to be on that line. So the x-coordinate of the vertex has to be 2 something. And to find out what it is, let's just think of this function, and we're going to plug 2 in for x and see what the y value is. So 2 squared is 4, minus 4 times 2, which is 8. 4 minus 8 is -4. So the vertex has to be on the AOS line, and it's going to be the point 2, -4. So that's going to be sufficient for our parabola. We'll just go ahead and draw through those points. Okay, now that we've got the parabola drawn, let's look at the inequality, because that's going to help us identify how to get to the answer. Because what this reads as is, where is this parabola above, greater than means above the x-axis. Well, above the x-axis would be this part of the parabola. So this is a little bit like we did on the previous problems, and this part of the parabola. Okay, so we're talking about the solutions being all of the x values that fall less than 0, because that's where this blue part that I've shaded is headed. For values less of x that are less than 0, the parabola is going this way. And for values of x that are greater than 4, the same thing is happening over here. Okay, so we're ready to state our answer based on the graph. All x's such that we have x is less than 0, or we have x values that are greater than 4. Okay? All right, and that's the final answer for number 9. Let's try number 10. Okay, let's think of this in terms of an equation in standard form equals 0. It does factor, so that's to me the easiest way to come up with the solutions. Think of the factored form, and the factored form then should lead you pretty nicely to the solutions, which is another way of saying the x-intercept. So we have an x-intercept at -4, and we have another one at +3. I know that the AOS has to be right in between, so if you want to do the opposite of b over 2a to find that AOS line, that would be okay, but I know that I can count, there's 7 spaces in between these, and the halfway point, if you just take half of 7, that's 3.5. So we have symmetry at the line x equals -1/2. And to find the y of the vertex, again, just think of this in terms of a function. So you're going to plug in -1/2 and see what comes out. So this is +1/4. I'll go ahead and change 1/2 into 2/4 so we can have a common denominator. So 1/4 minus 2/4 is -1/4, and then -1/4 minus 12 is -12 1/4. So we're doing -12 and then just a little bit more on this AOS line. 2, 4, 6, 8, 10, 12, and then just below that. Okay, let's sketch our parabola. And once again, now we're ready to look at the inequality. And again, I'll go to this one since it's set equal to 0. We'll just change that to greater than 0. And this reads, where is this parabola? What part of this parabola is above the x-axis? So once again, I'll just shade that part. Okay, now let's think of the x-coordinates on the red part of this. Okay, so above the x-axis, these are going to continue to be above or continue in this direction for x values that are less than -4. And that's also going to be true. This red part on this side will continue to head in that direction for values of x that are greater than 3. Now, so far we haven't looked at less than in this case, so let's just say, for instance, we won't change the whole problem, but what if this did say less than? Well, that indicates what part of this parabola is below the x-axis. Okay, so we'll just do that in green. And now we're wanting to know all of the x-coordinates that would be on the green part. And so now, if it did say less than, we would be talking about all of the x's in between -4 and +3. Okay, just wanted you to see a quick example of the difference since both of our examples contained greater than. All right, so once again, same instructions to solve by graphing. Here we're going to make this an equation equal to 0. It doesn't factor, so we use the quadratic formula. 4 times 4 is 16, times 9 is get my calculator. 16 times 9, that's 144. all over 2 times 4, which is 8. Well, before we go any further, we see the discriminant. That's this part underneath the radical, and it's a negative number. A negative discriminant tells you that you do not have any x-intercepts. Okay, there are no real number solutions to this. Therefore, what we have, since this is never going to cross the x-axis, and it has to open upward because this number is positive, we have a parabola that has to be somewhere up here above the x-axis. So I'm not going to draw the exact graph. I actually think this is one where you have to solve algebraically. So, but let's just take a look at this little rough sketch of some parabola that opens up lying above the x-axis. Well, this says, tell me what part of this parabola is below the x-axis. Well, none of this parabola, no points on this parabola fall below the x-axis. Therefore, the final answer to this is going to be no solution. So the bottom line here is, if you do end up with a negative discriminant, I would personally, if your quadratic does not factor when you're looking for the x-intercepts, I would do the discriminant first. If the discriminant is negative, you know you don't have any x-intercepts, then pay attention to how the quadratic opens. A is positive, it opens up. If A is negative, it opens down. And then you can tell your answer is either going to be no solution, like this, or if this had said greater than, meaning what points on this parabola fall above the x-axis, then we would have an all real numbers solution. So it's got to be one or the other for a negative discriminant. Okay, so I've shown you how to solve by graphing. Let's take a look at how to solve algebraically. Well, first of all, we've got to do a little bit of work on this to get it in standard form. So 5x. Let's put this as an equation equal to 0 temporarily so we can come up with the solutions. Okay, this does factor, and I showed you a quick review of the box method. Whenever the number in front of x squared is greater than 1, the box method is handy to help us with factoring. You just put the first and the last terms across from each other, multiply those together, and we're looking for the factors of this product that add up to this middle term, negative 5x, and that would be negative 9x times positive 4x. And when you found those two factors, you just put those in the other squares, and it doesn't matter where. You'll get the same answer. And now when you find all the GCFs, both rows and both columns, you will have your factoring. So the GCF of this top row is 2x. The GCF of the bottom row is negative 3. So there is one of my binomial factors, 2x minus 3. The GCF of this column is 3x. The GCF of this column is 2. And so there's another, the other binomial factor. And it's from the factors that we're able to solve. One of my solutions is positive 3 over 2. And the other one is negative 2/3. So solving algebraically involves this. You don't have to do any graphing. You just put the two solutions that you got on a number line. Just think of where they would go on a number line. And then you're going to do testing. So basically these two numbers divide your number line up into 3 sections. And it's from each of these sections that you're going to test a number. Okay, so that should be negative 2/3. Alright, so let's just pick a number that's less than negative 2/3, like negative 1, and plug it in. You can plug it into the original. You can plug it into the inequality after you've solved and just think of the standard form. It doesn't really matter which one you plug into. I'm going to go to the original, and let's see what we get. 6 times negative 1 squared is 1. 1 minus 1 is 0. And is that greater than 5 times negative 1? Is 0 greater than negative 5? Yes. So what we've proven is that all the numbers that are less than negative 2/3 are going to make this true. It will satisfy this inequality. Okay, let's pick a number in between, like 0. That's always an easy one. And I'm going back to the original problem. And I get 6 times 0 minus 1, that's negative 1. Is that greater than 5 times 0? Negative 6 greater than 0? No. So the numbers in between negative 2/3 and positive 3/2 do not satisfy. They will not be part of the solution. So then the final step is to pick a number greater than 3/2, like 2. All right, so go back to the original. 2 squared is 4. 4 minus 1 is 3. 3 times 6 is 18. 18 is greater than 10. So all the numbers greater than 3/2 will satisfy this inequality. So we're ready to state our answer. All x such that x is less than negative 2/3, or x is greater than 3/2. And then just one final thing, if this had said or equal to, of course, then both of these would be or equal to. Okay, so that is the lesson. I hope that this will help you with the other problems that you have to do. If you have any questions, let me know.